Now I want to analyze unsymmetrical faults. So what are symmetrical faults? Symmetrical faults are nothing but it can be a fault like this. All three lines are getting short circuited and then ground is also getting short. This is symmetrical fault. What about unsymmetrical faults? So unsymmetrical faults in a three-phase system is nothing but two lines are getting short circuited. One type of symmetrical fault. Or one line is getting short circuited to the ground, or L and G. So this is also another unsymmetrical kind of fault. So one of the line is getting connected to ground, two lines are getting shorted, or two lines getting shorted to ground. So all these three, so these unsymmetrical faults will result in unbalanced fault currents. So we have already studied how to analyze symmetrical faults. Today we are going to start studying about unsymmetrical faults. But before I move forward, any doubts regarding symmetrical faults you have from the previous lectures, please feel free to ask now. Any doubts based on this up to here? I'll ask a question. What is balanced system? So in a balanced system, the currents, magnitudes are same and phase differs by 120 degrees. So that means if I have, this is the IA, current in the A phase. So the same magnitude will be followed by IB. So the length of this is equal to the length of this. And this angle is minus 120 degrees or 120 degrees in the clockwise direction. Because anti-clockwise direction is considered as the positive direction. Now 120 degrees behind that, you will get another IC. So this angle is again 120 degrees and this angle is again 120 degrees. So we have angles like this. So the magnitudes are equal. So magnitude of IA equal to magnitude of IB equal to magnitude of IC, and phase of IA, phase of IB and phase of IC differ by 120 degrees. So this is the definition of a symmetrical or balanced system. So balanced system, or you can also call it a symmetrical. Now, what about voltages? I am just talking about currents. Okay, so the same conditions apply for voltage also. A set of three-phase voltages can also be balanced and unbalanced. So typically what happens, the generation, let's say you are generating balanced generation, and then it is causing unbalanced currents. So the voltages will be balanced, but the currents will be unbalanced. So that can happen. So this is the question: what is balanced system? Now, if I again ask a question, what is unbalanced system? So of course, just the answer is, if it is not balanced, then it is unbalanced. So just take an example. So let's take, this is my IA, and let's take this is my IB. and let's take this is my IC. So you notice magnitude of IA. So this is phi A, this is phi B, and this is phi C. So magnitude of A, magnitude of B, magnitude of C are all different magnitudes, and also angles are not separated by 120 degrees. Then this is an example of a unbalanced system. Now next question I can ask, how unbalance occurs? So the answer can be the loads are unbalanced or there is an unbalanced fault. Okay, so let's do an example. So the example is like this. So a three-phase four-wire supply has phase voltage of 100 volts per phase. So this is actually a balanced supply. Supply is balanced, voltage supply. So the loads are 1 plus J2, 3 plus J2, J10. So these are all loads on each phase respectively. So find neutral current. So this is the question. So what is the current in the neutral wire? We will have to find out. So can you try to solve this? So I'll just give you maybe 2 minutes. Just read the question and then see what you can do about it. Just take a couple of minutes. Think about the question. Also find line currents. Three-phase four-wire balance supply. So first I'll draw the supply. Three-phase four-wire. That means it looks like this. 1, 2, 3. These are three-phase lines, and then this is the neutral. So A, B, C, N. So this is the neutral wire. So this is A, B, C, and neutral. Now what are the loads? So the loads are 1 plus J2, 5 minus J6, and 3 plus J10. So let me indicate three loads here. This is the first load, this is the second load, and this is the third load. So Z1, ZA, ZB, ZC. I have three loads which are here. 1 plus J2, 5 minus J6. 3 plus J10. Now, how are they connected? So, the first load is connected to A phase. So, you take the A phase tapping here and then directly connect to the first load. So, it's not connected to B or C and directly connected to the A phase. The other end is connected to neutral like this. So, similarly, you go to the second phase, B phase. So, it is tapped again from B line here. I'll just draw directly. And then here it is tapped to north. So these are the two tappings. So therefore this is in the B phase. And finally the third one is connected to C phase here and then it's connected to neutral here like this. So if I can mark the currents, load currents. So how the load currents will look like? This is IA, the A phase current. So this is IB and this is IC. So if you look at what is happening, this IA current will come like this and then go to the neutral. So here IA is going back to the neutral. Similarly, the IB current will come like this and then go back to the neutral. So this is IB. Similarly, the IC current will also go back to the neutral. So here, if you look at what is the total current, so IA plus IB plus IC. So this is the total current. So IN is IA plus IB plus IC. So this is the neutral current. Now in a balanced system, you know that IA plus IB plus IC is equal to 0. So IN equal to 0 in a balanced system. So IN not equal to 0 in unbalanced system. In fact, you see this system is unbalanced because the impedance in A phase is different from impedance in B phase, which is also different from impedance in C phase. So let's do it. So how do you find IA current? So IA is nothing but VA by ZA, IB is nothing but VB by ZB, and finally IC is nothing but VC by ZC. So like this we can do it. Or if I put it in matrix form, so VA, VB, VC. So I equal to VA, VB, VC dot slash ZA, ZB, ZC. So this is nothing but element wise division. So VA by ZA, VB by ZB, VC by ZC. I'll get the currents. So let's, what is the value of VA, VB, VC? Now if I go back to the question, here 100 volts is given. So this voltage is 100 volts. So this is 100 volts with respect to neutral. So always we measure the voltage with respect to neutral. So VA, also you can say VAN is 100, angle 0 degrees because I am taking that as reference. Therefore, what will be VB? Nothing but VBN will also be 100 minus 120 degrees. And finally VC will be VCN and magnitude is 100, angle is minus 240 degrees and so on. So now I know the voltages, I know the impedances, I can find the currents. So for doing, so can you try doing this calculation? So I'll just leave it to you. Just take a couple of minutes. Can you calculate what is IA, IB and IC? So can you calculate what is IA, IB and IC? Okay, so good. So I got some answers from DMSS VCHE. So let's wait for some more answers. So I request answer from, okay, so Jntuk Kakinada also submitted answer in a different format. So is this both same? So it appears that the answers are somewhat correct, but then we still need to confirm. Any other college want to submit answers? Okay, so one more answer we got. So this is where it is interesting. So IA current is same here, IB current is also same, but IC current is different. 6.56 plus J 6.97, whereas here it is minus 9.31 minus J 2.2. So slightly different value. Okay, so I got one final answer. Let me paste that here. My actually running out of space. Okay, so I think I'll go with this. So there are some differences. You see, uh, here the angle is positive. So so here the angle is positive, but here the angle is negative, and here the 170 is there, and here minus 69 is there. So 193 and this one. So there are a lot of differences in your answers. So let's match your answers and then see what is the correct answer. Okay, so Poti Sriramlu want to correct this thing. So let me change this. Okay, so so let's do. Let me just do it myself. So how do we solve this? So I'm going to my MATLAB interface, and in this MATLAB interface, I'm going to show how to solve it. So what are the things that we need to define? So for example, here VAN equal to 100 volts, and how to define the angle? You have to say into EXP I into 0 into 180 by pi, or into pi by 180 degrees. So this is the procedure for defining the A phase voltage. Similarly, let me do V phase voltage, VBN, VCN, and then here angle will be minus 120 degrees, and here it will be minus 240 degrees. So as a result, what will be the, I'll just VABC equal to VAN, VBN, VCN. I'll just transpose that matrix. Then I'll get the voltages. So if I run the program, on the right hand side, you can see the voltage values are displayed. So these are the voltages of A phase, B phase and C phase. Now let me define the impedances. So what is the impedances Z, A, B, C? So the first impedance is 1 plus J2. The second impedance is 5 minus J6. And the third impedance is 3 plus J10. So I am defining like this. So let me execute this. Now on the right hand side, you can see the voltages are defined and the impedances are also defined, three phase impedances. Therefore, now if I calculate what is the currents, IABC. So VABC dot slash. So this dot is important because I want to do element wise division. Not a matrix division, it's an element wise division. So now if I execute this, so here is what I am getting the currents. 20 minus 40i minus 12. So these are the correct values of the current. 3 plus J10. Okay. So I want to display the currents in polar form. So IABC absolute value, and then angle of IABC into 180 divided by pi. So if I do this, then I can display the angles also. So on the screen we are getting. So here IABC magnitude IABC angle. So simple MATLAB code I have run to display the final solution. Okay, so let me copy the solution. The solution after MATLAB code. So did your answers match? So this is the final answer. So 44.72 minus 63. So let me just go and check your answers. Okay, so I'm just checking the first answer. So this is correct, this is wrong, and this is also wrong. The next one, 44.72. Okay, so this is correct. And 12.8 angle 170 degrees. So this is wrong. And then IC 166. Magnitude is correct, angle is wrong. Coming to the next one, this is correct, 4.8 So this is wrong. This is also wrong. And what about the next one? So here the angle is wrong, so this is wrong. And then IB, this is correct, whereas this is wrong. So you notice that when you look at the submitted answers, first of all, not all colleges submitted, only 1, 2, 3, 4 colleges submitted. And out of that also, all correct, nobody has got. So I've been saying many times, practice these things. This is the simple Ohm's law. If you notice what he had done, just taken the voltage, divide by the getting correctly. So that is something serious in my matter. So try to practice more. So any doubts you have regarding this, any doubts or did I make any mistake? You can always point out if there's something wrong in my program coding or anything. So any doubts up to here? So you can once again have a look at the program. So the program is very straightforward. You look at the code on your screen. Everything is self-explanatory there. So I'm defining A voltage, B voltage and C voltage. In line numbers 3, 4 and 5, the voltages are defined and you know how to do this. So why you have to do pi by 180 is to convert the angle into radians. And then, so that's what you can see on the right hand side, the voltages are coming. So is it correct or is there any mistake? And then we have ZABC, the impedances of all three phases. Then I just divided the impedances to find the current and then absolute values and angles and so 41.7 amperes, 12.8 amperes, 9.5 amperes, and these are the angles. Problem here, I think there's a problem in my code. Let me just correct it. So here the problem with the transpose. So I'll just build it like a column matrix here. So let me just run it. Okay, so now I think I have the correct answers. I was just looking at the voltages, so they did not seem correct. I think some error. So IABC is 44 point. Oh, I'm sorry. So these are the correct answers. Let me just paste this. So these are the correct values. I'll just take the angles and paste it here. So let me go back and correct your submissions. Okay, so these two are correct. This is correct and this is correct. So all three answers are correct here. What about the other one? Okay, this is also correct. And the last one is also correct. Good. So this is also correct. No, this one is wrong anyway. Good. So we had found some mistake in the MATLAB code and we have rectified it. Now we are getting correct answers. Okay. So now let's draw the. Any doubts so far? So we'll do the vector diagram. So this is IA, this is IB, and this is IC. So this is the angles for each. Now 44 magnitude. So angle is minus 63. So if I take this as the reference, then minus 63, I am getting this one. So IA equal to 44.7 amperes. And this angle is minus 63. Now there is another current IB that is 12.8 amperes. So the length is very less, 12.8 amperes, whereas this angle is minus 69.8 degrees. So I have marked two currents. Now what about third one? 9.57. So this one. So this is even smaller. IC equal to 9.57 and this angle is 46.6 degrees. So these currents are unbalanced. Now we can ask the question, what is the neutral current? So neutral current is nothing but IAN plus IBN plus ICN. So actually this N will not be there, IA plus IB plus IC. So this is very easy to find. So just go back to the MATLAB code. So here IN equal to sum of IABC. So I want to display the IN magnitude, absolute value of IN, and then IN angle, absolute value of IN, sorry, angle of IN. So the neutral current, so I am getting magnitude and angle. So on your screen you can see on the right, this is the neutral current. 54 amperes is flowing in the neutral wire. So therefore IN is 54.67 angle of minus 55 degrees. So finally now if I want to mark the solutions, so I get like this. So now actually we'll come to today's topic. Any doubts up to here? So symmetrical components method. So this is introduced by C.L. Fortis in 1918. So in the year of 1918, almost like we are in 2017. So about 99 years ago, this symmetrical components method was invented. So almost learning that today in the class, that is the symmetrical components method. So what the symmetrical components method is saying is, so you have three phase unbalanced currents. So by doing this one, I can just separate this into three components. The first component is positive sequence. The second component is negative sequence. And third component is zero sequence. That means if I add this positive sequence plus negative sequence plus zero sequence, I'll get the three phase unbalanced currents. So positive sequence will be nothing but balanced three phase currents. This is again balanced three phase currents. So, but then this is negative sequence, and whereas this one is balanced three phase currents. In fact, I cannot say balanced three phase currents, we will say three equal currents. Like this. So this transformation is called symmetrical components method. So either I can go from unbalanced, I can go to components, or from symmetrical components I can go to unbalanced components. So I can convert it. So let me explain what this is. What are positive sequence currents? So positive sequence currents. See, every time I am writing currents, it does not mean that it's only always currents. You can also apply for voltages also. Then negative sequence. currents. And finally, zero sequence currents. So what happens is positive sequence currents are like this: IA0, IB0, IC0. So A will be leading B and B will be leading C. So this is positive sequence. So sequence is A, B, C. So whereas negative sequence, if you come, what we have is something like this. This is IA, I'm sorry, this is 1. This is not 0, this is 1. IA1, IB1, because it is positive sequence denoted by 1. So IA2, and then here IB2 will be here. So this is 120 degrees, and then this will be IC2. So IC is leading IB, IB is leading IA. So like that. So here what is the sequence? We will write ACB. In other words, A is first and then C and then B. Like that also you can write it. Now what is zero sequence? The zero sequence is like this. IA0 equal to IB0 equal to IC0. So all are pointing in the same direction. So these are the three different components. So what they are saying is any unbalanced system can be expressed as per this one. Okay, so if you look at this once again, so what is the relation here? So IA1, so from the positive sequence, so before I talk about this, let me talk about the A operator. So what is this A operator? So take A equal to 1 angle 120 degrees. This is a constant complex number. So multiply any phasor with A, then it will rotate by 120 degrees. So take an example. Let V equal to 100 angle 0 degrees. Find AV, A square V, A cube V. So three things I want to find out. So what is AV? Nothing but 1 angle 120 degrees multiplied by 100 angle 0 degrees. So the magnitude will remain same, just 100 will be same, whereas the angle will increase by 120 degrees, like this. What is A square V? So 1 angle 120 degrees into 1 angle 120 degrees into 1 angle, sorry, this 100 angle 0. So again 1 into 100 will be always 100, and this angle will be 240 degrees, and so on. So, and what about A cube V? So 1 plus 1 angle 120 into 1 angle 120 into 1 angle 120 into 100 angle 0 degrees. So if you look at this 3, 1 into 1 into 1 is 1, 120 plus 120 plus 120 is 360 degrees. 360 degrees is nothing but one full revolution. So you will again get the same component. So this is 100 angle 0 degrees. So like this. So this is the effect of A operator. So, so note, so a cube equal to 1. Now what, I'll take one more example. Also, one more example I'd like to take, that is, let I equal to 5 minus 30 degrees amperes. Find IA, find A into I minus A into I. So these two things I want to find out. Or A square into I. So, so can you try this? Hello? 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 Yes, sir. Good morning, sir. Pradeep here. So let me do this. So what is AI? So I just write 5 minus 30 degrees plus 120, I'll do it. So this is 5 angle 90 degrees. Now what is A square I? So, or sorry, minus AI. So multiplying with minus AI is nothing but rotating clockwise. So minus 30 degrees minus 120 degrees. So this will be 5 angle minus 150 degrees. This is amperes, by the way. So what is A square I? So A square I is 5 minus 30 degrees and then plus 240 degrees. So square means plus 240. So that is 5 angle 240 minus 30 is 210 degrees. Now, so this one is also equal to, so if any vector is there, so you just look at the diagram. So if the angle is 210, so this entire angle is 210 degrees, which is also equal to, if I count from this side, so this will be 90 plus 60, 150 degrees. So this is also equal to 5 angle minus 150 degrees. So you notice that, so either I can measure from the top clockwise direction, positive angle to 210 degrees, but if I measure from the bottom, so, or if I measure in anti-clockwise or clockwise direction, so it is 5 angle minus 120. So what do you notice from this? So here minus AI is nothing but A square into I, or minus A equal to A square. So okay, did you see this? In fact, I can directly prove also. Direct proof. So what is that? So minus A equal to minus 1 angle 120 degrees. That is 1 angle minus 120 degrees. And that is angle 240 degrees. So that is nothing but 1 angle 120 into 1 angle 120 degrees. So that is nothing but A square. So minus A is A square. So this also you notice. So rotating clockwise by 120 degrees is equivalent to rotating anti-clockwise by 240 degrees and so on. So anyway, so enough about this A operator. Let's see how it is used. So what I'll do now is I'll share between this ABC and HCP. So if I select this, I'll just make a copy of this. page. So look at this. IA1 equal to, because IB1 is lagging IA1 by 90 degrees. If I just, sorry, 120 IA1. Or in other words, I can write IB1 is nothing but minus A into IA1, or which is nothing but A square into IA1. Similarly, you see what is IC1? IC1 is nothing but A into IA1. So I want to express everything in IA1. So what I'll get? So IA1 is equal to IA1. IB1 is equal to A square into IA1. And then IC1 is equal to A into IA1. So I can represent everything in terms of IA1 and this one. Look at the negative sequence currents. So what is IA2, what is IB2, and what is IC2? I want to express in terms of IA2. IA2 is nothing but IA2, just both are equal. IB2. You look at the diagram, IB2 is here. So how to get IB2 to IA2 position is, so if I multiply A to IA2, it will become IB2. So A into IA2 is nothing but IB2. A into IA2. Similarly, IC is A square into IA2, like this. So now finally, what about IA0? So IA0 equal to IB0 equal to IC0. So I have this. These are my positive sequence, and this is my negative sequence. So now the important point that we are coming here, that is, let IA, IB and IC be three be the three-phase currents. So these are in general any three-phase current, they may be balanced or unbalanced. So now what I want to do is this set of three currents IA, I want to express as positive sequence component plus negative sequence component plus zero sequence component. So on the left hand side is my three phase quantity, on the right hand side I have sequence component. Again, all these are vectors, by the way. Similarly, the IB current I want to express in the form of IB1 plus IB2 plus IB0. So the B phase current I want to express positive sequence B phase current plus negative sequence B phase current plus zero sequence B phase current. Similarly, the C phase current I want to express as IC1 plus IC2 plus IC0. Like this I want to express. But now I can replace IB with IA. So what do I get? So IA, IB, IC is equal to, so IA1 plus, see IA1 and IA2 both are same. You look at the diagram. So this is just exactly same as this one. So I'll just keep it as IA2 plus IA0. Now look at the second one. Here IB1 A square into IA1. So this will be A square into IA1 plus in the negative sequence it will be A into IA2 plus IA0. Sorry, IB0, which is nothing but IA0. Similarly here IC, what is IC1? That is A into IA1 plus A square into IA2 plus IC0. So these all we just substituted from the previous step. Actually I want to rewrite it in this form. IA0 first, then positive sequence, then negative sequence. Similarly, IA0 plus plus, and this will be A square into IA1, this will be A into IA1, and this will be A into IA2, this will be A square into IA2. So finally this, if I want to write it in the form of a matrix, IA0, IA1, IA2. And the matrix is 1, 1, 1, 1 A square A, and this will be 1 A square. So this is, so this is the IABC matrix. So, or IA, IB, IC is equal to capital A multiplied by IA0, IA1, IA2. So that means if this is known, then simply multiply, this is just a constant matrix, so multiply it with, and then you will get the ABC. Now what about the reverse one? So if I want to know reverse, that means if I want to know IA0, IA1, IA2, then I should do A inverse of IA, IB, IC. So if the phase currents are given, I can find the components. If the components are given, I can find the phase currents because I can find A and A inverse. Now what is A inverse? So A inverse is 1 by 3, 1, 1, 1, 1 A square, 1 A square A. So this is the A inverse matrix. Now you can ask, how can I write like that? Is there any proof? So the proof you can actually verify it right away. Let's do A inverse into A. So what do we get? First A inverse I'll write 1 by 3, 1, 1, 1, 1 A square, 1 A square A. This one I want to multiply it with 1, 1, 1, 1 A square A, 1 A square. Now if I want to do this multiplication, so what is 1 into 1, 1 into 1, 1 into 1. So it will be 3. Now 1 into 1, 1 into A square, 1 into A. So this is 1 plus A square plus A. And the last element also 1 plus A square. This one is 1 plus A square. And then this one will be 1. A into A square is A cube. And you know A cube is 1. Similarly, A square into A is A cube. Again it is 1. So this will be again 3. And finally this will be second row into third column. So 1 plus A square plus A to the power of 4. This one is and finally this will be 1 plus a cube plus a cube. So 1 plus a square plus a equal to 0. 1 plus, by the way, what is a to the power of 4? A to the power of 4 is nothing but a. Because 3 times you multiply, it will be 360 degrees. The fourth time you multiply, it will be just a. So therefore, 1 plus a square plus a to the power of 4 is also equal to 0. So then I get 1 by 3 into 3, 3, 3, 0, 0, 0, 0, 0, 0. This is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is nothing but your identity matrix. So, so therefore it is true. So this is your identity matrix. Okay. So any doubts up to here? So what we have done is so far, so far what we have done is this one. This is important. How to transform between the two cases. So I'll just do one final example here. So maybe I'll do it in the next page. So I'll give you the currents. The currents are what we already did. This one. So, so now the question is find the sequence components. So these are all currents in amperes. So find the components. So it's very easy. So what you have to do, just IA0, IA1 and then IB1 is equal to, sorry, IA0, IB0 and IA2. This is zero sequence, positive sequence and negative sequence is equal to the A inverse matrix multiplied by IA, IB, IC. So this is what we have to do. Okay. So let me put some comments. Calculation of neutral current. This is calculation of line currents. Okay, so now I want to do this. So what I'll begin by doing is I'll define the A matrix. Okay. So what is the value of A? A, I said it's a constant. So it is 1 at an angle of 120 degrees. So I into 120 into pi by 180 degrees. So I'm defining the complex number A, and then I'm building the A matrix. So what is A matrix? 1, 1, 1 is the first row. 1 A square, A is the second row, and then 1 A square is the third row. So this is the A matrix. So if I now execute the code, you can actually see the A matrix. So if I run this code, so you can see on the right hand side, this is the A matrix. Column 1, column 2, and column 3. So now I can find simply I 012, IA 012 is equal to. So I'll just take the IABC. So inverse of A multiplied by IABC. If I simply do this, then I'll get the sequence components of the currents. Very simple calculation. So you notice here IA0, we are getting the sequence components of the currents. So if I want to know the magnitude and angle, so that's also I'll do. So IA012 magnitude is nothing. IA012 IA012 angle multiplied by 180 divided by pi. So again, it's a very simple code. So here, this is calculation of sequence components. So again, I hope you are following this. So let me just run this. So finally, I am getting like this. So let me paste it here. So I got these values. So therefore, IA0 is nothing but 18.2 minus 55.4 degrees. This is the neutral, that is the zero sequence current. And then IB0 is nothing but 16.68 minus 51.8 degrees. This is the, IA1, positive sequence current. And then IA2 is nothing but 11.89, angle is minus 93.115 degrees. like this. So here I am getting these three currents. So what is the actual value of IA? So you want to verify it. Okay, verification. So how to do verification? I can just add all these three. So IA0 plus IA1 plus IA2. If I add the zero sequence, positive sequence and negative sequence, then I should get back my original IA current. So will I get that or not? So let me just verify. So again I'm going back to my MATLAB interface just to verify that I'll get back what is my IA this one. So I'll simply say sum of IA0, 1, 2. I'll just add the all these things. Now if I once again run this code, so finally I'm getting 20 minus 40. So here you can see on the screen the answer is there. So this is nothing but 20 minus J40. So if you remember, this is nothing but the correct value of IA. Now I want to do one more verification. So this is verification of IA. So I want to verify IB. So what is IB? IB is nothing but IB0 plus IB1 plus IB2. Now what is IB0 is nothing but IA0. What is IB1? So IB1 is nothing but A square into IA1. You remember the positive sequence current, if you want, you'll be getting like this. And then IB2 is nothing but A into IA2. So I have the individual values of IA0, IA1 and IA2. So simply by multiplying with this, I'll be getting the IB value. So I'm sorry, I did not share the screen. So verification of IB is nothing but the sequence components 0, 1 and 2. So this is nothing but IB0 is nothing but IA0. IB1 in terms of IA1 I have to give A square and so on. So from this I'll get the sequence component. So this I think I'll just I'll leave it for homework. Similarly, verification of IC. So is IC equal to IC0 plus IC1 plus IC2? So this is what we'll have to verify. I think we are almost up to the time. Any doubts you have today so far? The unbalanced currents, and once you have the unbalanced currents, how to express them as currents. So as always I have been saying, try to take any textbook, you have problems, you solve them, and we will discuss further in the next class.